Hey Chris, um, I'm still a little bit under the weather, so I'm going to hold off on the handstand punishment for another episode or two. But I'm looking forward to this one. It's a pretty interesting topic, I think, so here we go. I'm going to talk about cholesterol, but not in the normal dietary it's normally talked about in. Yes, the is a technical term. But no, like it can be a problem if you have too much. If you intake too much cholesterol, it can greatly increase your risk of heart attack. That said, it also does some really cool stuff in the body, and one of those is regulate membrane fluidity. So, um, by the way, my note cards are back. Here's the structure of cholesterol, and here is the building block of a membrane. This is a phospholipid. It has a hydrophilic head and a hydrophobic tail. Um, what they do is they kind of like two of them will kind of join up together like this, and then you have a wall that's hydrophilic on both sides and hydrophobic in the middle. It becomes semi-permeable, and that's how you get a semi-permeable membrane, and that's how all of life's functions function. Um, so, there are basically two types. There's saturated and unsaturated. Unsaturated is the type that plants have. That's why it can be liquid at room temperature. Um, and that's why you get something like olive oil, vegetable oil, etc. So like I said, the kinks in the fatty acid chains are really what makes the difference. Those are from unsaturation points, and that makes it a lot easier to pull them apart. So as you heat up things more, they start moving and they move around each other much better. That makes them a liquid, as opposed to a saturated fatty acid, which loops around each other a lot like this, and that takes a lot more heat to really melt, and so they'll hang on like this together until you get enough heat for them to really go around, and that's why they're solid at room temperature. It may seem like we want our membranes to be solid at room temperature, but that is not the case. Have you ever seen a gravy boat? When you let gravy sit out for too long and it kind of congeals on the top. Know how easily that ruptures like that? We don't want that in our cell walls. No, we want liquid cell membranes. This was supposed to be a gravy boat. I got bored and I turned it into a genie halfway through. But yeah, it's pretty cool. We want to maintain a permeability and a movability and motility in our phospholipids, and so they move around and they create what's called a fluid mosaic, with a bunch of proteins and stuff interspersed, and that's what allows the membrane to be dynamic and respond to changes and not rupture and cause the cell's guts to spill out everywhere. It's a pretty cool idea and a really neat concept. Anyway, yeah, so what cholesterol does is cholesterol actually will get in between the fatty acids and decrease a lot of their interactions. You can see it's got a lot of rings in there, and the rings kind of help force it apart. It's very hydrophobic, so it's going to stay within the membrane. It's a really cool phenomenon, and that's one of the main ways the our membranes are able to stay fluid, and the concentration will change relative to temperature, so that we'll have it liquid no matter if it's 0 degrees or 50 degrees Celsius. Actually, I don't know. At 50 degrees, we might start to die. It's whatever. So I'm about to run out of time. I'll talk to you tomorrow, bro.